So we've got a table and a scatter plot again. It says that is also shown on the scatter plot below. And then it says, write down the equation of the regression, use it to estimate the price of 1 meter squared of land 4 kilometers from 4 kilometers from the city center. Okay, and then we want to be able to state whether it's estimated reasonable or not. Sorry, I'm reading as I'm talking. So I guess when I made this, I took some of it off because it was a lot longer question and we didn't need all of it just for practice here. I guess I took off the part about finding those two values. So we got an x value of a giving us a 1.8. So the 1.8 dot is going to be right there. So that's going to be 2.24, all right, because those lines are 0.2. So that's 2.4. I can't get the regression equation unless I have these anyways. And then 4.8 gives us a value of, let's see, what are these going up here? There's 1, 2, 3, 4, 5. So they're going up a tenth on the vertical axis. I got to figure that out. So 4.8 is 0.5, 6, 7, 8, 9. 0.9. Okay, so I found those. So now I can bring my calculator up and I can find the regression equation. So stat, edit, figure my previous lists out. So 1.2, 2.4, 3.1, 3.3, 4.8, 5.2, and then 2.4, 1.8, 1.4, 1.3, 0.9, and 0.8. Okay, so there's that. So then stat, calculate, number 4. All right, so I don't need the correlation coefficient this time. It's there, and I can see that it's pretty strong. All right, so then my slope is 0.392. So my regression equation is y equals 0.392x. 2.74 is my y-intercept. So plus 2.74. All right, so it says use the regressional equation to estimate the price of 1 meter squared of land 4 kilometers from the city center. So the kilometers is the x value. I always double check that before I do it. So y equals 0.392 times 4 plus 2.74. So 0.392 times 4 plus 2.74. 4.308. So 4.308. Whoops, there's no that. I gotta get that. All right, so 4.31 to 3 significant figures would be what I have there. Sorry, I got my pen on the screen. Okay, so 4.31, it says state whether your estimate is reliable and justify your answer. So it's reliable because it falls in our 1 to 6 domain. So I would say yes, it's reliable. Because of interpolation. Okay, that's enough. You could say it falls between 1 and 6, and the x values, that would be fine also. But if I use the interpolation word, then I don't have to deal with doing any more complicated of an explanation.